So we're going to use this file, the one that I just sent you, regression using R, November 16. It already contains some of the codes in the R file that I sent you before, which were blank. So because of time constraints, I have to do that. Okay, kindly access the packages that we're going to use: Psych, Pastex, OLS, RR, and Stargazer. And then please import the wage data. You have that data already, guys. Okay, 8 variables containing 526 observations. Okay, once you have imported it, guys, kindly please chat yes, so that I know you're ready to continue. Okay, thank you, Matthew. Okay, good. Okay, thank you. Okay, let's wait for your classmates. Okay, so while our classmates are still uploading the file, how do we access the data? How do we access the data that we uploaded? We use the view function. Okay, we know that the view function, guys, will allow us to see the wage data in a data frame like this in the tab in R Studio. Okay, so could you kindly please run this? I will not run it anymore because I already have it. Okay, and what does the names function give us? When we run the names function, it gives us the names of the variables. Okay, so the wage data has these variables: education, experience, etc. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I won't be discussing this anymore because we have done this before in the past. So this is just a quick review. The head and the tail function, you know it already, guys. The head function will give us the first 6 rows by default, but you can define the number of rows that you want. Okay, tail naman, also the last 6 rows, but also you can define the number of rows, the last rows. Okay, now yung number 1, yung head function, wage 10 is similar to wage 1 to 10 here. Okay, the brackets will allow us to subset the data. Okay, the first number here, 1 to 10, is a number of rows. Okay, the second number is a number of columns. If you don't reflect the number of columns, then it means that you show everything. Okay, so I won't compare anymore. Okay, yung head, this code row 95 and this code row 97 will yield us the same results. Okay, and then for the structure function gives us the different data, different variables there, and it gives us the data type. Okay, so this is a data frame. Okay, 526 observations. You know what a data frame is? It's a rectangular array consisting of rows and columns. Okay, so there are 526 rows and 8 columns. The columns should have their own distinct names. Okay, so if we take a look at our wage function, okay, may mga labels yung mga columns, no? Education, experience, hanggang hourly wage. And then also the same number of elements for the columns. So if education has 526 entries, the experience and hourly wage, all of them should also have 526 entries. Okay, all in all. Although sometimes there might be some missing data or missing values, but the count should be 526, including the missing data. Okay, so that's what the structure function gives us. Okay, and then here, class, ano yung class ng education? Okay, the class tells us what data type this variable is, yung education. And that education comes from the wage object. Okay, if we just write class of education, mag-error siya because hindi nare-recognize yung R yung education. Okay, we don't have here an object called education. Education. We only have wage. So dapat identify natin yung object and then the column. Okay, yung race then guys, race, it's a character variable. Although sabi natin, race, technically ang race dapat later on pag nag-regress tayo, it should not be treated as a character. Okay? Rather, it should be treated as what? As a letter F, guys. Letter F as a, anyone? So race, yung variable na race, that should not be treated as a character. Rather, it should be treated as what? As letter F. Okay? Factor, no? Factor. Ano ba yung factor? Ang factor, guys, it may be numeric or character, pero it's used to classify. It's used for classification. For example, yung wage natin, si race. Ito, class niya, character. Pero pag gagamitin natin sa regression yan, when we use it to distinguish between white and non-white, kasi yung data natin white and non-white, no? If you're going to use that as classifiers, no? Iba yung mga white, iba yung mga non-white, then this should be converted as a factor siya, no? Hindi character. So we'll learn that as we go on. And then summary, guys, anong ginagawa nito? Ito yung 6-number summary, no? Okay, depende yan kung anong klaseng, ano yung data type. Pag quantitative, it will give us the minimum, the maximum, the first quartile, second quartile, and the third quartile, and also the mean. Okay? For those variables that are character, data type, for example, yung race, yung bilang lang, no? Kasi it doesn't make sense, hindi naman natin makukompute dito yung mean, median, first quartile, etc. So only the quantitative variables can we get the 6-number summaries, no? Yung minimum, maximum, first quartile, second quartile, third quartile, okay? Yung second quartile siya yung median, di ba? And then also the average, which is the mean. Okay, so very quick review yan, guys. Okay? All right. So in your project, kunyari sa paper nyo, kailangan i-present nyo rin yung descriptive statistics. Sa thesis nyo, kailangan din yan. So there are several ways in order to present your descriptive statistics. Pwede natin gamitin yung describe ng psych package. So very quickly, guys, describe function. Okay, so this is the namesake. Okay, psych. It means it came from the package psych. Of course, we can delete this. Okay. So here, describe. What will this give us? Okay, some descriptive statistics measures of your, in particular, your quantitative. So yung race, gender, civil status, naka-asterisk siya. Ibig sabihin, these are quantitative variables. So walang ibig sabihin yung mga mean, median yan. Okay? No meaning at all. Ang may mga meanings lang yung mga quantitative variables. Okay? It includes like the standard deviation, trimmed median, mean absolute deviation, the range, which is that's the difference between your maximum and your minimum values, skewness, kurtosis, standard error. Okay. However, guys, that's not the subject of this course, so I leave guys to you. If you have forgotten those measures, yung skewness and kurtosis, you can easily review that, guys, in basic statistics. Okay. So here we use describe them. We can also use the paste text function, the stat.descriptive. Okay. We can get different information also from this one. Okay. Ito, guys, yung ito ang arrangement naman sa paste text. Yung variable yung nasa column, tapos yung mga statistical measures yung nasa rows natin. Okay. How many? Yung value, null, ilan yung missing daw, ito yung null. Okay, ilan yung not up, NA, okay, mean, maximum, range. So may mga similar dun sa describe function ni psych. Okay, So here you have standard deviation also, confidence interval, variance, standard deviation, and coefficient of variation. Okay. So that's one way. Although personally, medyo hindi ko gusto yung pag-present ng ano no ng paste text. Okay. So here guys, ano tong options na to? Kasi yung paste text natin, let's run yung paste text again with options digits. Control enter. Okay, hindi siya para doon. Okay, so sorry. Yung options digits na to, it's for Stargazer. Okay, so si Stargazer guys, ang gagawin ni Stargazer, wage, tapos type is equal to text, digits is equal to 2. What does the Stargazer function give us? Run nga natin. Okay, so this is also one way to present your descriptive statistics using the Stargazer. Ang kaganda ng Stargazer function, naka-tabular, ano siya, tabular form. No? Okay, so it gives us the count. Ang present lang niya guys yung mga quantitative variables, hindi niya sinama yung mga qualitative variables. Standard deviation, minimum, first this is the first percentile, this is the third percentile, and the maximum. Okay? Wala dito yung second percentile, which is the median. Okay, then another one, itong Schema from the Schema package, yung Scheme. I also like this, I like the Scheme function. Okay, ito yung Scheme function, guys. Meron pa siyang konting histogram, no? Okay, so let me increase the width of the. Okay. Yeah. Okay, so this is the Scheme function. It also gives us, it classifies yung ano natin, yung data natin. Okay? Number of rows, number of columns, name, wage. Okay, ilan daw yung numeric, ilan yung character. Okay, may bilang siya dito. Okay? And then sa character, ito yung mga character variables natin, si race, si gender, si civil status. Ilan yung missing? Okay, ilan yung minimum, maximum, number of unique. Okay, number of unique, yung race, dalawang level siya, dalawang klaseng values. Okay, ito yung white and non-white. Gender, male, female, kaya dalawa din. Civil status, single or married. Okay, so not much information about the character variables, qualitative. So sa ano naman, sa mga quantitative, okay, ito yung mean, standard deviation, minimum, first quartile, second quartile, third quartile, maximum, and there's a sample histogram. No? Kikita natin dito yung mga, kung sino yung mga skewed to the right, skewed to the left. Si education medyo may pagka-konting normally distributed. Okay, pero iba talaga may skewness. No? Okay, so may nag-chat. Quick question, what's the name po ng package ng Schema? Okay, Schema, okay. Yung package is Schema itself. Ito, no? Ito yung namesake niya. So, hindi yata natin na ano, no? So, if you want to install the package, okay, install that packages. Okay, and then Schema. Okay, so this is the package for Schema. Updating, sabi one or more will be updated. Okay. No na, no? Okay, ang sabi niya, error in install that packages. Ano yung mali po? Updating loading packages. Okay, hindi pa ba na-install sa akin yan? Check ko lang guys ha. Packages. And then Schema. Okay, so the name of the package is Schema. In fact, nag-error siya. Saan yung nag-error dito? Ayan guys, no? Ito. here. So may package na Schema. Okay? So if you want to load it, then ito yung gagamitin natin, Schema, install that packages, and then i-library natin. Okay, did that answer your question, Ronnie? Okay, thank you. Thank you for that question. Okay. Okay, so then let's have a brief, I think we plotted this last time, no? Okay, so quickly lang guys. Okay, this is coming from the base R. Okay, from base R to, no? So plot. So this is the x-axis, education, hourly wage is the y-axis. Then we have the title of the plot, main, scatter plot of education and hourly wage. Okay, we did that last time. You can, of course, you can expand the plot. Okay, dito, okay, and dito si, nga pala, this will not work, no? Kasi hindi niya mara-recognize si education at saka si hourly wage. So dapat ito guys, dapat pag pina-plot natin, so dapat naka-identify yung variable kung anong object siya galing. Okay? Wage, education, wage, hourly wage. Unless guys, you can do this without identifying the wage. How do you do that guys, if you recall? Paano natin mapaplot to without including the object from where these variables came from, yung wage? Dapat, do you recall guys?
Attach, sir.
Yes, thank you. Correct. Tama. Thank you for it. No? Attach. Dapat isama natin attach and then wage. And when we do that, guys, any variable which we will identify, automatically malalaman ni Aryan na galing yan kay wage. Okay? But it's good to do that if you're only working with one data, yung wage lang. Pero pag if you're working with several data, guys, I suggest you don't do that kasi pag in-attach mo yon, tapos gagamitin mo yung ibang data set, guys, magkakaroon ng conflict, no? So ang gagawin mo, attach mo na, tapos i-detach mo na muna bago mo magamit yung ibang data set. So anyway, maganda rin to guys kasi alam natin kung saan galing yung education, saan galing yung hourly wage. Okay? Alright, so okay. So ano itong nangyari dito, no? Okay, let me, dito, dinagdagan lang natin ng plot character. Okay? Plot character 19, ibig sabihin kasi sa plot character ni R, there are different types of let's see if this will be generated here. Tingnan ko lang, PCH. I'm not sure if R has a say help on that. Okay. Okay. Okay, walang PCH. Okay, PCH. Ito. Plotting character, no? Plotting character. Okay. No, hindi nakalagay. Ito pala guys, sorry. Hindi dito pala, no? So ito yung plotting character natin. Okay, so there are different types, 25 all in all, no? Plotting character. Yung 0, rectangle, yan, etc. So PCH is equal to 19, ito yung ginamit natin, yung maliit na black circle, or we could have used yung 20, mas maliit na black circle, etc. So depende dun sa gusto nyong gamitin na plotting character. Okay? So PCH is equal to 19, solid circle. PCH is equal to 20, it's a bullet, smaller solid circle, no? 2/3 daw ng size of 19. Okay? So nakakatulong talaga din yung information, no, ng help function ni R. Okay, any questions guys about that PCH, yung plot character na yan? Okay, so dito ginagamit natin, we're using the plot character is equal to 19. Okay? PCH 19, and then frame is equal to false, ibig sabihin hindi lalagyan ng ng line yung yung plot, no? So subukan natin i-plot to, yung pangalawa. Control enter. And then we have here yung plot, no? Hindi nilagyan ng ng frame. Paglagay natin ng see, frame is equal to true. Frame is equal to true. Okay, let's see. Control enter. Okay, so this is what it gives us. So naka-frame yung yung plot natin. Okay. Now, another modification here. Kasi yung x-axis natin hanggang 15 lang. No? I think we were trying to do this last time kaso nag-error tayo. No? So same thing, dinagdagan lang natin na axis. No? 1, ibig sabihin x-axis yan. Pag ginawa natin 2, ang minomodify natin na axis yung y-axis. So sequence is 0 from 0 up to 20 and then increments of 5. So dapat hanggang 20 yung natin, yung x-axis. Okay? So let's run this. Run natin to. Control enter. Okay, I hope tumama na siya. Okay, nagkakaproblema pa rin ako, no? So I don't know why it's not. Sometimes guys, okay siya, sometimes hindi. So I don't know why. Ngayon hindi ko hindi ko ma-decipher kung bakit hindi lumalabas yung dapat may 20 dito eh. May 20. Okay, what if I change this to gawin natin 25? Sige nga. Let's see. What happens? Tapos i-frame natin, ilagay natin frame is equal to true. Okay. Ayaw pa rin, no? Ayaw pa rin. May mali kaya ako dito sa axis ko. Okay, wait ha. So axis. Okay. Axis. Side, okay, ito di ba? Integer specifying the side of the plot to which it is to be drawn. Okay, ang side niya, pag 1 below, pag 2 to the left, 3 to the right. Okay. Yung side niya, so below. Tapos, okay, maraming details, Okay. Axis 1, 1 to 4 letters. So here are some examples that you may wish to use. Okay, axis 3. Below pala yung 1, no? Okay, sorry. 1. So how do I change? Asan yung okay, sometimes guys, kailangan ng medyo patience, no? Kailangan mong medyo hahanapin talaga. Labels, tick, line, position, outer, font, okay, line type, line width ito. Line width. Okay, so I can't see it right now, guys. Okay, sige, iwan muna natin yan, guys. Hindi naman siya ganun ka-importante. Okay, so here I'm not able to generate. 1 kasi is below daw, no? So that's yung side. 1 below, 2 is equal to left, 3 is equal to above, 4 is equal to right. So hindi pala yung sequence. Below nga, pero ang sequence niya dapat by 5. Okay, hindi ko pa makuha, guys. Huh? Okay, let's leave that, guys. I'll leave that also as an exercise for us. Tingnan natin kung paano natin mamomodify yung plot so that ang pangit kasi, guys, na hanggang 15 lang. Pero I did this before already. Tapos umokay naman. So minsan, guys, you have to really explore kung bakit hindi nag-work yung code, no? Flat character. Okay, sige. So let's move on, guys. So sabi natin, ang pinaka-main topic natin dito is regression. And we use the function LM, okay, for linear model. Later on, guys, mag-ano tayo ng iba like GLM, that's generalized linear model. That's what we use when we do logistic regression. So ngayon, LM muna tayo. And ang simula natin, guys, is a simple linear regression. Okay. Here, I told you that yung race, kailangan factor siya, hindi siya character. So in order to convert a particular variable into a factor, especially mga character variables, kung gagamitin natin na factor yan, this is the code for that. So from the wage object, in particular yung race variable, as that factor yung wage $raise. Okay, so that's how you do that. Even gender and even civil status. So why are we converting them into factors? Because although they're characters, yet they're used as classifiers. So kapag classifiers, guys, yung character variable natin, we convert them into factors because we can use them as independent variables later on, as predictor variables. Tapos ang advantage nun, i-differentiate niya between the levels of the factors. Okay? Whether it's gender, kung female o male, kung ginawa natin factor yan, then it will be treated as a factor, ibig sabihin as a classifier. Okay, so let's run this. Let's run this and then, so makikita natin yung class ngayon, factor na, no? Si wage. Okay, kasi tinanong natin, ano na ba yung class ni race? Kanina character yan eh. Ngayon, ano na siya, yung factor. Okay, so if we get the structure, for example, structure of wage. Kung kinuha natin si structure ng wage, makikita natin na yung mga character variables natin are no longer, hindi na siya characters. Diba? Kanina characters kasi siya. Ngayon, they are now factors. Race, sasabihin kung ilang levels, ilan yung different levels ng mga variables na to. Si race kasi dalawa, non-white at saka si white. Ganun din si gender at saka ganun si civil status. If there were, let's say, 4 different types of, let's say, gender or civil status, then gagawin niyang factor with 4 levels. Madidetect ni R kung ilang levels ng factors ang gagawin. Okay? All right. This one, I mentioned this a while ago, yung attach, no? Attach. So pag nag-attach tayo, okay, we can now use the variables without using the wage function. Okay? But for us, guys, okay, for us, hindi ko na gagawin yan. Lalagyan ko na lang dito ng ano. I'll just put here, okay, wage. Wage. Para hindi na ako magdita. Sige, okay. Sige, pwede na lang, no? Okay, so I'm going to attach yung wage. Okay, so since naka-attach yung wage, guys, I can now get the correlation of 2 variables, no? 2 quantitative variables, education and hourly wage. Okay, so this one, yan, makukuha natin yung 0.41. Okay, so okay, ano nangyari dito? Correlation ng wage. Okay, error. Bakit correlation ng wage, guys? Sinabi natin correlation ng wage and nag-error siya. Bakit nag-error? Kasi yung wage contains factors, no? Contains yung mga factors natin, hindi naman pwedeng kumuha ng correlation with character variables or factors. So, pwede natin kunin yung correlation lang ng lahat ng rows and also negative C 4 to 6, ibig sabihin do not include 4 to 6. Column 4 to 6. Kasi ang column 4 to 6 natin, 1, 2, 3, 4, 5, 6. So 4 to 6 natin are our factors or our character variables. So kung kukunin natin yung correlation, only those that are quantitative. Si education, si experience, si number of dependents, and hourly wage. Okay? So yun, no? Correlation ng wage lahat ng rows kasama, okay? Pero tanggalin natin negative C means do not include column 4 to 6. Okay, so let's now run this. Okay, and it will give us a matrix. Okay, so andyan dyan yung correlation matrix ng, okay, we expect that the correlation of the variable with itself, yung diagonal, should be 100% yan. Okay, and the rest will be mirror images yan. No? Okay, like experience with education will be the same as education with experience. -3, -3. Okay, so these are, they have the same correlation. So sometimes makikita mo that R will only give the output yung upper right lang, upper or lower. Okay, those values above the diagonals or those below the diagonal, since pareho naman yung mirror image niya. Okay, any questions so far, guys? Okay, sorry for accelerating the pace a bit kasi nga grabe ang bilis ng time. Ano na kagad? Okay, bilis kagad, less than 1 hour na lang tayo. Any questions so far, guys? Paki-chat naman please kung clear so far yung discussion natin. Am I going too fast? No?
Clear, sir.
Okay, thank you. Thank you. Okay, good. Salamat ha. All right, so let's now go to our linear model. I think we did this last time. I think natapos tayo sa ano sa yan sa ito dun sa sa regression diagnostic. So quickly guys, i-run lang natin to. Okay. So we're creating a model called model 1 here. Ito yung object natin, and we're getting the linear model between hourly wage and education. Okay, data is from wage. Okay, now natapos natin i-ano kanina, no? Pwede na natin guys para hindi nakakalito din, pwede niyo i-detach, no, yung wage. Kasi lalo na paggagamit tayo ng iba pang data set, sabi ko nga, it's a good practice. If you attach it, so you're only going to use that for that specific chunks of codes, and then i-detach nyo ulit para magagamit nyo rin yung ibang data set. No? Okay, so let's do that as a practice. I-detach naman natin si wage. Okay, so when we run this again, guys, when we run this again, hindi na naman mag-work to. Kanina nag-work to, di ba? Itong correlation, education, and wage. When we run this again, what happened? Okay, nag-error na naman, no? Di ba? Nag-error na naman siya kasi dinetach na natin si wage. Okay? So hindi na naman na-recognize ni R, saan galing tong education and hourly wage na yan? Okay? So just to show that when we detach wage, hindi na mag-work tong correlation ng education and hourly wage. Kailangan naka-attach naman dyan yung wage dollar education, wage dollar hourly wage. All right. So here, we're creating a model, linear model. Hourly wage will be regressed on education. So we would like to know, ang dependent variable natin dito, yung nasa left, no? Si hourly wage. We'd like to know how hourly wage can be described by education. Related ba sila? Kanina, ang lumabas na ang correlation niya, 0.41. No? So, hindi kataasan. No? Kasi nung prinat nga natin, di ba? Nung prinat natin si, let's go there once again. Naka-preserve ba yung plot ko? Okay. When we plotted hourly wage and correlation, what did we find? Ito. No? Ito na lang, yung unang-una. Hourly wage and education. Okay. Oops. Wala pala. Mali. Kasi walang to. Ito na lang. Sorry. Ano pala to? Dapat may wage. No? Okay. Plot. Okay. So we notice hindi naman siya kalakasan yung linear relationship, no? Kasi when we go to several sa years of education, ang laki na ng variability, no? Kunyari sa 15, ito sa 16 siguro to, no? Ang laki na ng ng hourly wage based on these years of education ranging from less than 5 up to more than 20. Okay, so here we can see that kita nga natin dito na ang correlation hindi mataas, no? Tapos pwedeng yung model nito, yung using education as a predictor for hourly wage might not really give us very strong or good results, no? Okay, sige. So let's do that. Asa na tayo? Here. Okay. So linear model, hourly wage, regression education. Take note, hindi na natin kailangan dito ilagay si wage, no? Dito at saka dito kasi dinefine naman natin yung data natin here. Data is equal to wage. Okay? And by including here, by including a parenthesis dito, open and close parenthesis, we are telling automatically, sinasabi natin kay R na i-print niya kagad yung result. I-print niya kagad kung ano yung laman ng model 1. Okay? Mod 1. Okay? So, control enter. So what happened guys, automatically nagbigay siya ng result. No? Ito. Kung hindi natin linagay yung open and close parenthesis ng mod 1, ito, if we didn't put this, hindi lalabas tong result na to. Okay? So ito, sinasabi natin, okay, our model 1 guys, ang formula niya is the hourly wage is regression education, data is equal to wage. And then since this is a simple linear regression, simple kasi iisa lang yung independent variable natin, so this will follow yung formula na hourly wage is equal to the intercept beta null plus beta 1 times education. So isa lang yung predictor natin. Ang predictor natin, ang value niya is 0.4541. Ito yung intercept. Okay, so let's get the summary of this. The summary function gives us a clearer picture of what the model 1 is all about. Okay. So ito yung summary natin. So mas maraming details na binibigay, no? Okay, number 1, binibigay sa atin yung residuals, yung error terms. So yung residuals guys, ang kino-compare dyan, yung model natin at saka yung actual value. Okay, so ang pinakamaliit daw na residual is negative 5.34. Ang pinaka-maximum na residual is 16.609. Okay, so we have here the regression results. Okay, I'm sure you studied this before. Okay, so ito na yung regression natin guys, no? Regression output. Intercept and your education. Then we have this very important values, standard error, t-value, and then probability. Okay, ano ibig sabihin ng intercept? This is the value of your, ito yung value ng ano natin, ng dependent variable, in this case, hourly wage. Okay, ito yung value ng independent variable natin if our predictor, which is education, is equal to 0. Okay, remember ano yung equation natin? Guys, ano yung equation natin sa model na to? Let me copy this. Punta ako dito sa okay. Okay, so let me first access ko lang yung ano ko. It's taking quite some time, okay? Very slow talaga. Bagal. Okay na ba? Okay na. Kinapi ko, no? Wait, stop thinking muna. Control V, kinapi ko pala. Okay, so here is our regression output, no? Okay, by now guys, dapat we should know how to create the equation for this. Simple regression lang to. Alam natin na ang dependent variable natin is hourly wage, no? So we write the equation hourly wage, ito yung variable natin, okay, is equal to the intercept beta null plus beta 1 times your education, educ, okay, plus a certain error term. Okay? So ibig sabihin guys, yung hourly wage natin, yung value ng hourly wage natin at saka ng education, pag kinompute natin, hindi magmamatch yan, no? Yung predicted value natin. So, to write the predicted value guys, di ba linalagyan natin, hopefully naaral nyo ito sa sa FinStar nyo. Okay. To write the model itself, okay, so this is, palitan na pala natin to, negative 0.09049 plus 0.5414 times education. Okay? So ito yung model natin. Wala na yung epsilon sabay kasi ito ibig sabihin to predicted value na, no? Okay, so what does this mean? The intercept in negative 9.049 yan, it means this is the value of your hourly wage when education is 0. So pag ginawa natin 0 to, ano mangyayari sa equation natin? Mawawala tong component ng predictor natin, di ba? Kasi 0.54 times 0 will be 0. Therefore, we're left with this one, 0.90, and it's equal to hourly wage. Okay, now take note, hourly wage is not statistically significant. Ito. Yung P niya is 0.19. Okay? Okay, remember that the null hypothesis here is, ang null hypothesis niyan, beta null is equal to 0. Okay, so since the P is 0.9, P is equal to 0.19, and it's greater than 0.05, which is usually the level of significance na ginagamit, no? Then we fail to reject the null hypothesis. Hindi natin marireject to. So beta null will be equal to 0, no? By definition. Okay, but usually yung intercept guys, we still use it despite the fact that it's not statistically significant. Ginagamit pa rin natin yan in order to predict our hourly wage. Kaya kasama pa rin dito yan. However guys, yung interpretation niya, for example ito, ano yung hourly wage when a person has no education? Kasi ito ibig sabihin, 0 education, ibig sabihin wala siyang years of education. And the value that we're getting is negative 0.9. So ang ibig sabihin nun, yung hourly wage niya, negative, siya pa yung magbabayad sa company. So it doesn't make sense, no? It doesn't make sense. So we do not really interpret yung intercept, no? Okay, but we just still use it as a predictor. Okay? So paano natin makukuha yung predicted value? Well, hahanap tayo guys ng value na education. Kunyari if education, so let's look at R, yung wage natin. Okay. So kunyari guys, si first person, no? 11 yung niya, 11 yung education. So how do we now compute for the predicted value? Okay? Ang predicted value ngayon will be, di ba, itong intercept, copy natin to, Control C. Okay? Ito na lang lalagay. This one plus, okay? The coefficient of education is this one. Control C. Oops. Okay. Control C. So this is your beta 1. Okay. Times, what is the value of the education? Kay first respondent, kay first observation, 11. No? So I'm going to multiply that by 11. Ito, by 11. Okay. So this is our predicted value for hourly wage. Control Enter. Kaya lumalabas 5.1. If you're going to use the model guys, ang estimated natin, ang forecast natin for a person with 11 years of education is that the hourly wage is 5.1. Okay? So that's for the first observation. No? Tingnan natin dito. Okay? Pero ang actual na hourly wage niya is 3.1. So dito, okay, sa first observation, ang predicted value natin is 5.1, pero ang hourly wage niya is 3.1, di ba? So ibig sabihin guys, may error tayo nito. Ang error natin is the difference between 5.1 at saka 3.1. Yun ang pinapasok natin sa equation natin. Okay, ito, no? Ito yung error term natin. Okay? para mag-equal tong equation na to. Okay, so ano ibig sabihin guys ng 0.54 na to? What's the meaning of this? So this is the marginal effect of education on hourly wage. And is this slope statistically significant? Okay ba na gamitin natin na predictor? Yes. Bakit guys? Kasi ang p-value natin is less than 0.05. And general rule is that when the p is low, when we say low, usually it's 0.05, the null hypothesis must go. Kasi guys, statistical test to, no? So ang statistical test natin dyan is beta 1 is equal to 0. No? Okay, so that's the statistical test. Yung slope for education is equal to 0. So ang conclusion natin, since p is equal to, that's 0.000, 15 zeros yan guys, no? 15 zeros tapos 2. That's the p-value. Since that one is less than 0.05, then we reject this null hypothesis. I-reject natin to, na beta 1 is equal to 0. There's a strong statistical reason to believe that the slope of education or the marginal effect on education on hourly wage is not equal to 0. So in this case, the estimated value is 0.554. So ano ibig sabihin ng 0.54 na to? Okay, you studied this in your FINTSAR, that for every 1 unit increase in your independent variable, there's a corresponding 0.54 units increase in your dependent variable. Okay, ulitin ko yun ha. For every 1 unit increase in your independent variable education, there's a corresponding 0.54 units increase in your dependent variable. So if we apply it to our model, for every 1 year, kasi ang education years, for every 1 year increase in education, there's a corresponding 54 centavos kasi ang hourly wage is in dollars, no? $0.54 increase in hourly wage, okay? And usually pag marami tayong regressors, sinasama natin yung ceteris paribus or all things being equal. Okay. Any questions so far, guys? Any questions so far?
None, sir.
Okay, good. All right. Okay. Okay, good. Okay, so simple linear regression pa lang tayo, no? Gusto natin umalis na dyan kasi gusto natin nasa ano tayo multiple. Okay. Ito guys, anong ibig sabihin nito? Residual standard error. 3.4 on 524 degrees of freedom. What did you remember, guys? Okay, ano naalala nyo sa standard error ng residuals? Ano naalala nyo sa degrees of freedom? Do you recall yung multiple R squared nyo at saka adjusted R squared? Okay, naalala nyo rin ba yung F statistic nyo? 103 on 1. Okay, do you recall this, guys? If not, guys, I would suggest that you please recall or try to review ANOVA, ha? Kasi ito ANOVA to, no? Analysis of variance. And okay, so siguro pupuntahan na lang natin to kapag multiple regression. But please try to recall, try to review ano yung analysis of variance. Kasi magkasama yan eh. Yung regression at saka analysis of variance. Okay? Can anyone tell me, guys, ano yung null hypothesis sa analysis of variance? Anyone? Do you recall, guys? Ano yung null hypothesis? Kasi dito sa regression, kinuha na natin yung we looked at the null hypothesis for each of our parameters, sa intercept at saka sa education. Dito, beta null is equal to 0. Dito, beta 1 is equal to 0. For the intercept, it's beta null is equal to 0. For the first variable here, beta 1 is equal to 0. Pag meron pang karugtong to, may iba pang regressors, guys, beta 2 is equal to 0. Beta 3 is equal to 0. So isa-isa yan, guys. Isa-isa yan natin tinitingnan kung significant ba yung impact, yung marginal impact ng mga different variables on your dependent variable, on your response variable. How about ito guys, sa ANOVA? Ano yung ano dyan? Okay, sabihin ko na guys, yung ANOVA guys is a test on the joint effect of your variables. So ang null hypothesis yan, sabay-sabay sila. Beta null is equal to beta 1 is equal to 0. Whereas sa regression, hiwa-hiwala yon. Beta null is equal to 0, beta 1 is equal to 0. Sa ANOVA, dito guys, beta null is equal to beta 1 is equal to 0. So we have here the p-value. Okay, p-value is again 0.002, etc. No? 15 zeros and then 2. So, ano yung ano natin nito? Ano yung decision? Based on the null hypothesis that beta null is equal to beta 1 is equal to 0. So we reject the null hypothesis that both beta null and beta 1 are all equal to 0. So there is strong statistical reason to believe that at least one of them, isa sa kanila guys, is statistically significant and has a value other than 0. So yun yung ANOVA natin, yung analysis of variance. Okay? So please try to recall that. Kasi gagamitin pa rin natin siya. No? Okay, here guys, this is a plot of the regression line. So again, we're plotting si education at saka si hourly wage. Linagyan natin ng label. Okay? And then pareho lang to kanina. No? Pareho lang to kanina. Okay, ang only difference guys is that here, naglagay tayo ng regression line. Okay, that's AB line. No? Ano yung AB line natin? From the LM model, hourly wage, regression, education, and then let's give a color to the regression line and we give it a color blue. Okay? So dito, sinusuperimpose natin dun sa plot natin ng education at saka hourly wage na ginamit na natin kanina, we superimpose this regression line. Okay? Ang function doon, AB line. Okay, so if you check that guys, AB line. Okay, AB line. So, make it a habit guys pag nakaka-encounter kayo ng function. Okay, ano daw yung ginagawa ng AB line? Let's wait. No? Yan, AB line guys. AB line. This functions adds one or more straight lines through the current plot. Okay? So, yung AB line nagdadagdag ng line. Okay, pero ang dinadagdag natin guys yung result ng linear model, ng linear regression where we are regressing hourly wage on education and we're giving it a color blue. Okay, so let's run this. Okay, and then we see that our model looks this way. Okay, bakit nagkamali? Okay. Kulang to ng ano? Data. Okay. Alright. Sorry about that, guys. Okay, pakilagyan na lang guys ha. Kulang yung ano natin, yung equation natin dito. Hindi na-recognize yung hourly wage at saka education. Kailangan nakasama yung data is equal to wage. Okay. Now, take a look at that, guys. So dito, ito yung mga actual data points natin. Tapos ito yung regression natin. Okay? Ito yung predicted value natin. So necessarily, guys, kunyari at this point, okay, at this point where, kunyari 15, at x is equal to 15, okay, ito yung predicted value natin. So the number of hourly wage is about mga siguro 7, no? 7 something. Okay? Pero guys, itong mga actual points natin, okay? So medyo yung iba malalapit dun sa predicted value, yung iba malayo. For example, this one, ito malayo siya dun sa regression line natin. So yung error nito, guys, mas malaki. So there will be residuals or errors that are that we have, okay, because our actual values do not fall on the predicted value on the regression line. Okay, remember linear model to, no? So we'll be generating a line, okay, and those that do not meet the line, okay, necessarily have residuals or yung deviations niya. Yung mga nasa line, guys, walang deviation yan kasi eksakto, no? Yan, may mga nasa line, mga eksakto. Pero marami ding wala dun sa line, no? Marami dun wala sa line. So what does this tell us? Okay, babalikan ko yung kanina, no? Babalikan ko yung kanina natin. What does this tell us? Yung output natin kanina. Dito tayo papasok sa R squared, guys, no? Ang ibig sabihin nitong 16.5 na to, na 16.5% of the variability of our dependent variable hourly wage can be predicted by can be explained by our model. Okay, so that's what that means, no? Na 16.5% lang ng variability ng hourly wage natin ang kaya ng explain ng model natin. Kasi ito yung model natin, di ba? Ito yung linear model natin, which is -9, di ba? 0.065. I don't know if I can write here. Let's see. Pwede ba? Hindi ako makasulat, guys. So this is your -0.9 plus 0.54 times education. Ito yung line na yun. No? So that's the line. Okay? So there are some data points that fall on the line. So walang errors yun, walang residuals. Pero marami, guys, na nasa labas. So which tells us that yung kaya lang i-explain ng model na to, okay, on the variability, on the variation, kasi yung si hourly wage natin nagba-vary-vary, ano? Ang kaya lang niyang explain 16.5%. Ergo, guys, around 83% ang hindi kayang i-explain ng model natin. Malaki, no? So maliit lang yung kayang i-explain ng model natin, 16.5% lang. So anong implication nan? Well, there may be other variables that can be used in order to explain hourly wage. Kasi dito ang ginamit lang natin yung isa lang, yung education. Pero may mga ibang variables pa tayo na pwede natin gamitin, no? Okay? So that's the meaning of this plot, no? Okay. So punta tayo dito, guys, sa sa residual analysis. Ito yung dito tayo nagtapos last time. Okay. Now, ano ba laman ng mod 1 natin? Remember, meron tayong mod 1, di ba? Okay, ito. Mod 1. It's a list. Naalala niyo yung list, guys? Anong ibig sabihin ng list? It contains different types of data types. No? Pwedeng may numeric, may vector yan, o pwedeng may list din yan. So let's see, ano ba laman ng mod 1 na yan? Yung model natin. Okay? So tingnan natin, may coefficients, may rank, may call, may residuals, may fitted values, may effects. Okay? Alright. So ito, guys, ang importante sa atin ito, there are some things that are important here. Number 1, residuals. So yung mod 1 pala natin, may laman yan ng vector ng residuals. Okay? So let's go here. Let's create an object called res. Okay? Res, guys. And then kunin natin yan from our mod 1. Okay? And then the residuals. Diba si mod 1, guys, may laman yan, diba? Isa sa laman ni mod 1 yung residuals. So this is how we access the residuals. Okay? Yan, guys. So tingnan natin, guys, ha. So nag-generate tayo ng isang object called res. Yan. Okay, so it's a numeric vector, 526 yung laman niya. Okay, tapos ano laman niya, guys? Ang laman niya are the residuals. Okay? So, yan natin ulit. Okay, so ito, no? Ano yung negative 1.95? Okay, ito, guys, kino-compare yung predicted value natin at saka yung actual value natin. Remember, di ba, predict natin yung predict natin yung observation 1 natin. Ano yung prediction natin doon? If you recall, guys. Ano yung predicted value natin? When we used, saan na siya? Di ba ito? Sabi ito, guys, di ba? 5.1, okay, ito yung predicted value, and then minus the actual value, which is 3.1. So ang difference siya mga 2, no? Mga 2. So binigay sa atin yung value ng residuals ng observation 1. Ito. Kasi ang actual value niya 3.1, And then, ang predicted value natin is 5.1. So, meron talagang may discrepancy, no? And what that discrepancy, we call it your residuals. No? Okay, so residual natin yan. Okay, ito. So, ang value niya is negative 1.95, no? Okay, negative 1.95. So ano lang yan, estimate lang yung yung kanina natin. So sabi natin around 2. So this is your actual value minus your predicted value. So 3.1 minus 5.1, hindi exact yun, is around negative 2. Okay, so that's your vector of residuals, no? Okay, pwede rin natin i-generate, guys, yung predicted values. Okay? So predicted values natin, okay, let's create an object called pred. And it's coming from mod 1. Yung predicted values natin yan, ang tawag yan, guys, fitted values. Remember, guys, ano yung laman ng mod 1 natin? Okay, ito. Residuals yung kanina, okay, fitted that values, ito yung mga, okay? Ito yung mga predicted values, ito yung mga residuals. Okay, so let's run pred. Okay, di ba? 5.05 kanina, in-estimate natin ng mga 5.1. Ito, guys, yung mga values ng model natin, ng predicted values natin using the model. Ano yung model natin? Negative 0.9 plus 0.54 times your education. Okay? Meron tayong mga values ng education. Ito. No? Ito yung mga values natin in education. This one, this one, this one, this one, this one. So if you use our model, guys, and try to predict hourly wage based on the model, based on the equation, okay? So meron tayong value ng predicted value, which is negative 0.9 times negative 0.9 something plus 0.54 times 11. So magkakaroon tayo ng value dito. Ang tawag natin doon, predicted value. Pag i-compare natin sa actual value, yun ang residual natin. Okay? So yung mga predicted value natin for yung mga years na 11, pare-pareho yan. No? Kasi pareho lang naman yung 11 natin. Pero magiging iba yung residuals niya kasi iba yung actual values. No? Ito 3.1, ito 3.0. Okay ba, class? Clear? Okay, kunyari, anong predicted value natin ng observation 1? Ano yung predicted value? Ibig sabihin, using the model. No? It was 5.05. Okay. Ano yung predicted value ng observation 3? 5.05 din. Bakit pareho? Kasi guys, pareho yung value ng education. No? 11, 11. So lahat ng mga 11 dito guys, o lahat ng mga 12, pare-pareho yan. Ang predicted value niyan, pare-pareho. Kasi isa lang naman yung parameter na ginagamit natin. Kunyari, itong number 5 guys. Itong 12 na to. At saka yung number 8 at saka yung number 9. Pareho yan. Tingnan natin ha. Number 5 daw, okay, 5.59. Number 8, 5.59 din. Number 9, 5.59. Okay? So you can see here that, kasi isa lang yung ano natin, yung minomodel natin, yung education. Then, pag pare-pareho yung value ng education niya, pare-pareho yung predicted value. Okay? Alright, so gawin natin dito, view, series seed. Okay. So ito yung mga residuals natin guys, no? Ito. So you have here a numeric vector. Ito yung mga errors natin. How did we arrive at this? The actual value minus the predicted value, those are your residuals. Okay? Sino naman si predicted? View predicted. So ito guys, no? View predicted. Okay, so ito guys yung mga ito yung result ng ginamit natin yung model natin in order to forecast hourly wage. Okay? Alright, pause muna ako guys. Clear ba so far?
Yes, sir.
Okay. How about the rest guys? Paki-chat naman kung clear so far tayo. Okay, good. Alright, thank you. Okay, kamusta yung pace natin guys? Mabilis ba ako o tama lang? Am I going too fast or are we just okay with the pace? Feedback please. Okay, good. Thank you. All right. Salamat ha. Okay, now we use a function, a package called broom. Okay, ano ba yung ginagawa ni broom? So siguro dalawang pag-package kasi, okay, dalawang question mark. Okay, so guys, si help function ni R, kaibigan natin yan. No? So pag may mga doubts tayo, okay, but sometimes guys, minsan mahirap kagad makita sa isang ano lang, sa isang question lang, ano? Kailangan you should study further kung ano yung mga okay, functions, kunyari package, no? Okay, lumabas na ba si broom? Okay, mas mabilis minsan guys dito. Mas mabilis dito, broom. Ayan o, broom. No? Okay, so si broom daw, click natin. Okay, yan. So si broom converts statistical objects into tidy tables. At table guys is a data frame. So ito yung package na to na broom guys, maraming functions yan. Tingnan nyo to. No? It has several functions. And you can download this from i-google nyo kunyari yung broom tapos yung documentation niya. In fact, andito siya. No? Can we find it here? Ito, user guides, package vignettes, and other documentation. If you click this, okay, asan na yung site niya? Okay, wala. Okay, but you can of course check this sa internet kasi ando doon guys yung PDF file ng information, documentation ng broom package. Okay, just for this one guys. Okay, sana na-install niyo na itong broom. So ako na-install ko na yan, kaya library na lang ako. Okay. Then here, guys, tingnan nyo we're creating an object called mod1. This is our model, yung regression model natin. That diagnostic, that metrics. And then we're using this broom package. And then the function is augment. No? Augment ng object natin na model 1. Again, ano si model 1? Ito yung regression model natin. No? So let's run this. Okay, so na-install, na-acquire ko na si broom. I-run ko to. Okay? So hindi pa lumalabas si kasi hindi natin linagyan ng open and close parentheses. Let me copy this. Control C, Control V, Control Enter para ma-print natin si yan. Okay, take a look at this guys. What is this object? Itong mod1.diagnostics. So it's also a table. It's a data frame, guys. It's a data table. So ang table, guys, data frame din yan. May special features nga lang siya. No? But it's also a data frame. So ito daw si mod1 diagnostic metrics. Okay, it also consists of 526 observations and 8 variables. So let me run this. Okay, tingnan nyo guys, no? Okay, here pinapakita sa atin yung actual value ng hourly wage. Okay, tapos ito yung independent variable natin sa education. Okay, tapos ito si fitted value. Ano yung si fitted value? Ito yung predicted value natin. So using education, ano yung predicted value natin ng hourly wage? Okay, so here you can see yung difference, no? Hourly wage natin 3.10 actual, fitted value natin or predicted value 5.05. Okay? So, meron tayong residual. Yung residual na yan, guys, it's a difference between your actual and your fitted value. Okay? So, meron pa tayong dot hat dito at saka sigma, we'll explain this later on. Cook's distance, ginagamit to para sa outliers and standard residuals. Okay? Okay, ito, kinonvert lang yung residuals natin into standardized, normally distributed residuals. Okay, but what's important to us now is yung fitted value, yung predicted value, at saka yung residual natin. Yung difference between your actual value and your fitted value. Okay, so here we can see that yung model natin, may mga residuals talaga, no? May mga error terms. In fact, yung iba, malaki yung iba, no? Tingnan nyo. Actual value 17, predicted value 7.76. Ang laki ng difference. That's why your residual is 9.573. Meron yung 16 na residual. Actual value 22, okay? And then predicted value 5.59 lang. Okay, so residual 16.609. Okay? So itong ano na to guys, itong object na to coming from the Broom package will give us some very important measures as far as model is concerned. Ang model natin si Mod 1, di ba? Okay, any questions so far guys? Clear tayo on the model, that diagnostics, that metrics coming from the Broom package. Okay, so this allows us to see kung ano yung actual value natin, ano yung predictor natin sa education, ano yung predicted value natin, at saka ano yung residual. Kasama din yung Cook's distance, so that will determine kung outlier ba yan, influential data ba yan. Kasi lalo na guys, kung malalaki yung residual, kung masyado silang malayo sa model, no? So we'll look at Cook's distance later on. Ano ba yung effect nitong Cook's distance na to? Okay, questions guys?
None, sir.
Okay. All right, sige. Now dito guys, okay, so maybe some of you have not used the ggplot2 package. Okay, this is a good package for plotting, no? So if you haven't studied ggplot2, pwede niyo tingnan yung yung kay Marin. Tingnan niyo yung ggplot2 niya. Marami ng videos guys on ggplot2. So let's access ggplot2. Hindi pa natin access to. If you haven't installed ggplot2, you may use this function, install that packages muna bago mag-library. Okay? All right. So once you have accessed ggplot2 guys, you can now create this command. So ito yung skeleton ng ggplot2. First, you identify kung ano yung data. Okay, so ipa-plot natin yung data na model 1.metrics. Then we identify aesthetics. I-identify natin kung ano yung x-axis, tapos kung ano yung hourly wage. Okay, and then maglalagay tayo ng geom point, no? Kung ano yung anong klaseng plot ang gagamitin. So sinasabi natin, okay, gumamit siya ng point, no? Geom point. Tapos meron dito, guys, stat smooth. Ang method is equal to lm. Okay, standard error is equal to false. Tapos, okay, you might not understand this at the moment, pero guys, just take my word for it. Ito, magpapasulat tayo ng mga segment, no? Ano yung segment? Okay, yung sa x-axis, kukunin niya yung end ng education. Tapos sa y-axis, i-aan niya sa fitted value. So ibig sabihin nito guys, magdodraw siya ng line from the pinakadulo ng x-axis, okay? And then i-connect niya dun sa fitted value, dun sa regression line. Okay, tapos color red, tapos may size pa ng point, it's 0.3. Okay, so let's run this, okay? Okay, as I said guys, okay lang muna kung hindi niyo masyado maintindihan to, no? Ang ginagawa nito guys, ipa-plot yung error terms natin at saka yung line, gagawa siya ng line dun sa okay? Let's take a look at this. Para makita natin guys yung ibig sabihin ng mga residuals. Okay, take a look at that. Okay. Can you see guys the residuals? Okay. So itong line na to guys, ito yung x value natin. Kinompare natin siya dito sa predicted x dito sa line na to. So this is the length of your residuals. So lahat ng mga red lines na to guys, these plots the difference between the actual value, yung mga dots dito guys, mga actual values yan. The difference between the actual value and the predicted value, yung nasa blue line. Okay? So kita nyo guys, konting code lang, ano? Sa Excel, may hirapan tayo niyan. So you can see here a sample of the power of R. Okay, so actually guys, marami mga lines yan kasi marami mga points tayo, no? So ito, from this one to this one, that's one line. From this one to this one, that's one line. Okay? So there are several lines. Lahat ng mga points dito, guys, pinoproject sila dun sa regression line. And those are the measures of your residuals. Yung difference ng actual value at saka ng predicted value. Okay? Now, anong method ang ginagamit sa linear regression model? Ang ginagamit, guys, is that you get the distance between the actual and the predicted. Okay? Get the distance between the actual and the predicted. Okay, bawat isa yan, ano? Bawat isa may kanya-kanya silang ano? May kanya-kanya silang ano? Kanya-kanya silang residual, no? Okay. Then when you sum that up, guys, ito positive. Tapos may mga negative tayo dito. And you get the average of the differences. What will you get, guys? So the average of the differences will be equal to what? Yes, correct. It's equal to 0. Kasi yun ibig sabihin, guys, ng average residuals natin. No? Okay, that's why we don't use the average residuals kasi 0 lang yan. So anong ginagawa, guys, sa OLS? OLS is ordinary least squares. No? So I hope you discuss this in your FINTSAR. Ang method ng OLS, guys, is the method that's used in linear regression. Ang ginagawa ng ordinary least squares, kinukuha yung mga distances na yan. So this actual minus the predicted value, and then ini-square siya. Squared. Ini-square, guys, tapos sinasum up lahat ng mga yan. Yung mga deviations squared. Now, of course, hindi na yan magiging 0. No? In fact, lahat yan sila positive na. Bakit positive? Kasi yung mga distances, whether it's positive or negative, okay, when you square that, positive na lahat yan. Okay? And then the regression line is that line that minimizes all the squared deviations. Okay, I hope you're getting me, guys. Now, I'm not going into this in details kasi I'm assuming that this has already been discussed in your FINTSAR. So FINTSAR na FINTSAR yan. So hindi na natin kukunin yan kasi ang focus talaga natin is more on the models. So just be aware, guys, na yung ordinary least squares, ang methodology na ginagawa dyan is to get the error terms, the residuals. How do you get the residuals? Kukunin mo yung difference ng actual value at saka ng predicted value natin, tapos i-square natin. Pag in-square natin, guys, yan, lahat yan, positive na yan. So hindi pwedeng maging average yung sum na mga yan, it cannot be equal to 0. Okay? And then, the ordinary least squares is the line that minimizes these squared deviations. Yun ang ibig sabihin ng ordinary least squares or method of least squares. Okay? Yung line na talagang minimum, yung mga squared deviations is called the line of least squares. And that line of least squares is unique. Ibig sabihin, iisa lang yan. Hindi pa pwedeng dalawa yan. There can only be one and one ordinary least squares. And that happens to be yung negative 0.9 natin plus 0.54 times your education. Yun yung ordinary least squares natin. Okay? That's the line of best fit because that's the line that minimizes the squared deviations. No? Yun ang line na minimize talaga yung squared deviations. Okay, in other words, guys, kunyari maghanap pa kayo ng isang line dito, kunyari ito. Okay, itong line na to. Pag in-add natin yung square deviations yan, guys, mas malaki yan yung square deviations niya kaysa dito. Ito lang yung line, guys, na pinakamaliit na square deviations. Wala nang iba. Nothing more, guys. Okay? Okay, so this is a very good illustration on how ordinary least squares is being generated or being determined. Clear tayo, guys, doon? Are we clear on that?
Yes, sir.
Okay, good. Alam nyo naman yung concept na yan, di ba? Yung OLS. Alam nyo na yung square deviations. Okay, i-square natin dapat, guys, kasi hindi pa pwedeng i-ano natin, guys, hindi natin pwedeng hindi i-square kasi pag in-add natin yan, magiging 0 lang yung sum yan. Okay? All right, good. Okay, so moving further, konting minutes lang tayo. Okay. Okay, take a look at this, guys. Siguro dito tayo matatapos, no? Okay, this one, this code now is we're going to plot yung model 1 natin. So this one means partition. No? Ipapartition natin yung number of rows 2 by 2. So ang mangyayari nito, ang output natin, 2 rows, 2 columns. Ipa-plot natin si mod 1. Si mod 1, remember, mod 1 is our linear model where we regressed your hourly wage on education. Okay, so if you take a look at this, guys, plot natin to. Ayan, okay? Your assignment will be, guys, to understand what this means. Okay, na-meet nyo ba to, guys, sa FinSTAR nyo? Pakichat nga kung yes or no. Did you meet this plot of residuals versus fitted, normal QQ plot, scale location, and residuals versus leverage in your FinSTAR? Okay, good. Good. This is an opportunity to learn, no? So ito, guys, using R, okay, using the partition yung pardon, no? Partition, okay, itong code natin, number of rows natin, 2 by 2, and then ipa-plot natin si model 1. Okay, I want you guys for our next meeting to learn ano tong unang to, no? What's this? Well, the first one, guys, is just your residuals versus your fitted. Okay? Ito lang yung plot ito yung residuals natin, mineasure yung residuals, tapos mineasure yung fitted values, yung predicted values. Now, in order for a model to be acceptable, dapat, guys, yung variation yan, okay, dapat constant. Ang problema nito, guys, yung model natin parang it's increasing over time. So which is actually a case of what we call heteroskedasticity. Dito makikita natin kung heteroskedastic yung distribution ng mga error terms natin. And we don't want a heteroskedastic distribution of our error terms. As much as possible, guys, dapat makita natin dito sa plot na to, walang pattern. Okay, walang increasing value. Kaso ito, guys, nakikita nyo, parang nagfa-fan out siya, no? Parang over time lumalaki siya. Okay, which is a violation of the assumptions of linear regression model. Okay? So let's stop here, guys. It's almost time. May I have just one last minute? Okay lang ba, guys? One last minute to paint saan tayo, saan ang gagawin natin next meeting?
Yes, sir.
Okay. Now, next meeting, guys, pag continue tayo, please make sure na nakahanda na tong mga nakarun na tong mga yung sa wage, okay? Narun nyo na rin yung mod 1, okay? Tapos na-install nyo na itong GG45. Okay? Kasi itong GG45, okay, if I pakita ko lang to, guys, GG45 is also a very good way to plot itong kanina yung partition natin, no? Okay, so pag na-access nyo na si GG45, okay, and then auto-plot, ang function niya auto-plot. Okay, yung mod 1. Okay. Yan. Yan na ba? Hindi pa. Tagal niya mag-plot. Anyway, guys, ang ipa-plot yan parang pareho na nasa taas. Okay, so for next meeting, kindly read through the other Ano ibig sabihin ng yan, guys? Okay? Mas gusto ko yung auto-plot ng GG45 kasi mas maganda yung pag-plot niya, no? Compared to the partition MF row kanina, no? Okay, so we can use as an alternative itong okay, naglolo ko na naman itong ko. Ito, guys, ito. So next meeting, guys, we'll attempt to finish all of this. So pakibasa na lang tong yung plot nito ng natin ng mga residuals, okay? And then next guys, titingnan natin tong multiple regression. As your assignment, guys, kindly, nagawa na natin to last time, yung ginawa na natin as factor. Pakigawa na yung unang multiple regression natin, no? So here, we're creating a model number 2. This time, LM natin sa hourly wage, tilde, then dot. Ano ibig sabihin tong tilde, dot na to? Ibig sabihin, isama niya lahat ng mga variables. Okay? Although pwede natin gawing hourly wage, tilde, and then natin education plus experience plus tenure plus race plus gender plus civil status plus numdep plus yun. yung 1, 2, 3, 4, 5, 6, 7 variables na yan. Pero ang shortcut yan guys, ang shortcut is yan, tilde dot. Ibig sabihin isama niya lahat ng mga independent variables. Alright, so that ends our discussion guys. May mga pakibasa na nito, no? So we will attempt to finish everything guys this Thursday. Okay, and then after that, magsi-stepwise regression tayo next meeting. Isama na natin to. Okay, and then after that guys, we'll go to other examples ng multiple regression and then move on to other special types. Gagamitin natin hindi si LM, si GLM na, which is gagamit yan sa logistic regression, multinomial regression, etc. Okay, thank you guys so much. Maraming salamat. Sana natuto kayo ngayon. Did you learn something today, guys?